These are intended for Christmas lights. So the Eneloops are fine, but they're about 2,000 milliamp hour. They're nice, and these things can be charged thousands of times. This current edition is 2100 charge cycles. The Eneloop Pros, they bump up the capacity to 2500 milliamp hour, a minimum 2450 milliamp hour. The compromise is that you go from 2100 charge cycles to 500. So these are nice, but you don't get the life of them. I mean, I don't know, if I charge the batteries once a week, that'd be maybe 2 years. So anyways, with the Eneloops, the Eneloop Pros, focus of today is these batteries that I found on eBay. This is actually a pack of 16. And I found these POWEROWL batteries. They're low self-discharge supposedly, but strangely, this was like, what? It's a UL recognized battery. And why that's strange is that most of these manufacturers just put the CE mark on them. I don't even know if Panasonic bothered with it, because the market doesn't really care about these batteries. There's been no explosions in mass of these. They will rupture if they're charged improperly, stabbed, any of these things. Short circuit, assemble, heat, or put into fire. Yes, they'll get unhappy because they contain energy, there's chemistry, there's stuff. Yeah, I found this interesting, and I thought when I first got it, I was like, well, that's bogus, because it's oftentimes that some manufacturers will put a lot of these symbols on there to make it look like it's more of an authentic thing. This interested me, and then the Shenzhen EPT battery company manufactures this POWEROWL rechargeable battery. And in the Amazon listing, someone was saying that the batteries are manufactured in China, but the cells are actually manufactured in Japan, which is interesting. I don't know where that person got that information from, because as you will see in a moment, there's not much inside this box. Let me just pop this little thing off here. In the box, you get just 16 of these batteries. So let's line them all up, and I will cut them open with, I guess I could probably just do this and open them up. So there's a couple things I wanted to show on the batteries before I throw them in the charger and do a capacity test. Here are the batteries. You know, one moment, I'm gonna get a scale. So let's check it out here. Let's check out what we got. How much stuff is inside of these? Let's start with zeroing the scale. There we go. Let's do it in grams. So we're starting with the Eneloop, and it weighs 26 grams. So standard Eneloop. The Eneloop Pro is 30 grams, 30 grams. And the POWEROWL, which is, so 2,000 milliamp hour, 2,500 milliamp hour. The POWEROWL is saying it is 2,800 milliamp hour. 1.2 HR6 AA, 2,800 milliamp hour. So that weighs what? 27 grams. Interesting. Just about around where the Eneloops were at. Let me make sure that's zeroed. Yeah, it is zeroed. So for comparison, let's pull out the 2.3 amp hour goal zero. That's kind of between the two of these Eneloops. 2,000 and 2,500, 2,300, 28 grams. The reason why I wanted to weigh them is I picked this up and I thought it would be beefier, like it would feel in hand a little bit more like dense, but they don't. I would think that there'd be more stuff rolled in here. So the POWEROWL, here's a couple interesting things that will be investigating, and what I'm going to do is, first part of this video is just kind of discussing it, the batteries, and then I'm going to run 2 sets of these through the battery analyzer, the Lacrosse Technologies BC1000, and get an idea of what the initial capacity is. A few interesting things to note is that while I thought that recognition mark on the back was BS, it's here again, but there's an MH number underneath this, and the MH number, which I'm going to jot down, is a 10257. That has me curious, because I am going to take a look into that, because you can look these things up on UL's website to see if it is in fact a UL recognized cell. They note something about the safety plug in the top of this thing. To the best of my knowledge, all these batteries are manufactured with a safety plug on top that vents in the case that the battery gets too hot and the battery starts to build up internal pressure. And then now I'm just going to throw them all in the charger, get them going, and I will come back with some preliminary testing. Yeah, several weeks have passed. And the reason why several weeks have passed is because the first tests on these batteries did not go so well. 2.16 to 2.18 amp hours at the 350 milliamp discharge. And after running that, it's way less than the stated capacity. That's somewhere, I think, maybe, yeah, it's about 76% of the rated capacity. And some of them were as low as 1.9, 1.8. So 1.8 amp hour of 2.8 amp hour is about 65%, 64.2% of the rated capacity. So disappointing. It didn't feel right to come back and just say, I bought these batteries, they were inexpensive, and they didn't perform to what they claimed. What I instead embarked on was seeing how these batteries performed. I ran them for about 3 weeks in various, I wouldn't consider them professional things. I mean, they're calling them professional care and low self discharge. They ran in Christmas lights, they ran in LED candles, and the capacity and the runtimes were not great, but they were okay. They were okay for a non-low self-discharge, 2 amp hour-ish battery. There's a couple of companies that are on Amazon, and there are plenty of companies on eBay that claim 3,000 milliamp hour, 4,000 milliamp, I mean, ridiculously high claims that just can't be met. So this seemed plausible because the battery I tested it with was the Eneloop Pro. Sanyo's Eneloop Pro says, at the bottom here, high capacity, ready to use rechargeable battery. The only other thing that they show on here is, on the packaging, these show 2550 milliamp hour, but they do put a minimum of 2450 milliamp hour on these batteries. So I decided to benchmark these, just to run a set of, I was gonna run a set of 4. There was so much variability in 4, I ended up doing a set of 8, which still had a lot of variability in the data. So I compared a set of 8 of these against a set of 4 of these Panasonic Eneloop Pro BK-3H CCA. So the first thing I did is I ran the cells through several charge-discharge cycles because they were running continuously, and they were charged at least 10 to 12 times. So they had way more charge cycles on them than what POWEROWL says in their manual, like charge 3 to 5 times or a few times to get the maximum capacity. Also, they were put through a refresh cycle because I thought perhaps they had sat for a long time and just needed to be refreshed. So that ran on all 8 cells. So I gave it every possible opportunity to prove out its 2800 milliamp hour capacity. And so there are 4 different test profiles that it can run in for the capacity test. Previously, when I would be testing my own set of batteries that I have, periodically checking the capacity on them, I would typically run them at the 200 milliamp charge, 100 milliamp discharge. And I would get somewhere in the order of 2.1 to 2.2 amp hour. They can be discharged at a very low rate, and there's such a low internal impedance that they still return a pretty high internal capacity. So when I ran these cells at that lowest one, I thought, okay, fine, perhaps the 350 milliamp discharge current's too high. So I went down to the lowest profile, which was 100 milliamp. And I thought, okay, that'd give it the best shot of yielding the highest capacity. It did not. The cells did very poorly with that test profile, which tells me 2 things. One, these are not low self-discharge batteries at all. And I used its own charger and yielded 2.05 amp hour average across the 8 cells, with many of them falling down into the 1.95, 1.96, well below 70% of their advertised capacity. So then I said, okay, you know what? I'm gonna try across all 4 test profiles and just see what happens. So I just took a set of 4 of them, ran them across all 4 test profiles, and surprisingly, some, not all, started to climb in their capacity when they were discharged more rapidly. Notably at the 350 milliamp hour to 500 milliamp hour discharge rate. So that got to around 2.3 amp hour for some of them, 2.32, really the highest being 2.32, I think, out of, yep, that was the highest. So 2.3 amp hour on one cell, and some of the other ones going up to 2.31. So at higher discharge currents, it can get up to about 2.26 amp hour average. But I must add that if you look at the chart here, the graph, the thing I appreciated, and I'm including the error bars, it's just the standard deviation. There's a huge amount of deviation between cell to cell. Like there's not really consistency between the cells. You have some that charge up really have quite high capacity, and some that then in the same test charge 200 milliamp hour or more below what the highest cell achieved. It's across all the test parameters. After I finished the test with the eight cells, and then I averaged them. So the average, basically, the highest we got was 2.26 amp hour across the cells. And I have to remind you that that's average. So if you're running a set of these in series, like in a set of Christmas lights or whatever, it doesn't mean you're going to get 2.26 amp hours. You're going to get whatever the weakest cell can output. So in many of these cases, the lowest, the minimum value is what you would be looking at. And even at the best case output, some of these were at 2.16, 2.03 at the highest average reported. The minimum cells were well down into the low 2.0 amp hour, maxing out somewhere around 2.05. Okay, I then moved on and wanted to compare it against a set of Eneloop cells, the Eneloop Pros, kind of what these are, to me, these are what they're aimed at competing with. But I took a set of Eneloop Pros, and these are from 2018. These are not new. I've had these are from, these are all date stamped. They're all marked August 2018. I'm not sure that's going to come up on camera, but there it is. Yep. So I ran those, and I only ran 4 because the standard deviation was minimal between the cells. And these are cells that have about 50 charge cycles on them. I ran the same test profile on 4 cells, and right out of the gate, the minimum current, the 100 milliamp charge cycle for testing capacity, yielded an average of 2.45 amp hour. So that's right at what these are rated for. With the minimum being 2.39. So one of the cells just eked out just below 2.4 amp hour. So, but the average came out to 2.45. As you went up in the test current, I was amazed because I've never tested them this way before. And it was only by doing the POWEROWL, trying to get the best performance out of these cells, that I ran the Eneloop Pros through the same cycle of testing, where I went to 250 milliamp, 350 milliamp, and 500 milliamp. And those, it just kept climbing until it got to 500 milliamp, then it kind of settled off, which was 2.58 amp hour average, 2.71 amp hour average, and then 2.68 amp hour average as it reached the 500 milliamp hour discharge. And it is important to note that in those averages, the deviation is minimal. When you're looking at the graph here, you see that there are error bars, there are the trend line bars, and there's some deviation there that's occurring. But because these are pro, they're designed for more high demand, high current applications. You can see as they get up to the higher demand, 500 milliamp and 350 milliamp, they kind of flatten out. There's not really as much of a deviation as there is in the first test, the 100 milliamp discharge test. But the most important thing is that you can see here on the averages, the first test yields an average of what they claim minimum on the cell, 2450. The remaining tests, the 250, 350, and 500, all go well above 2.55 amp hour, with one data point falling below 2.55. That was a second cell in the 250 milliamp hour discharge test. So okay, fine. One cell fell below the package claim rating, but they said on the cells 2.45. And so in all of the data, there's one value of 16 that fell below 2.45. And it was a difference of 2.4%. So in that one test where it was 2.39, it was 2.4%. And I'm thinking the tolerance of this charger is probably, I don't know what it is. I might test it in another video, but I'm gonna go with about probably plus or minus 5% on that. It's not about taking the values that you get out of this and going, well, that's absolutely what the capacity is. You know, the temperature in the room matters, the humidity actually matters as well, and all the environmental variables are pretty consistent. My point is that the POWEROWLs, the deviation from what they're claiming is so large. It's way larger than any tolerance on the charger. So I conclude with this. If you happen to have bought a set of these POWEROWLs and you're looking at them going, why is the performance not that great? This is why. And okay, they can be charged 2,100 times. That's what it is. These are rated 1,200 charge cycles, which to me, there's no evidence backing that up. So I would take Eneloop's claim because they show that they've done testing to specific IEC standards, battery life based on IEC 61951-2. I don't see that anywhere for the POWEROWLs. If you're buying batteries that you're going to be using in high demand applications or continuously running applications, like I'm going to charge up a set of batteries and throw them into a set of Christmas lights or throw them into a set of LED candles, anything that's continuous duty and doesn't really care about low self-discharge, then these might be okay. If the alternative is you won't buy rechargeable batteries and you'll buy alkaline batteries instead. If you are buying these for use in things like remote controls and flashlights or things that are intermittent duty and you're expecting kind of like that same performance as you got on an alkaline battery, these will disappoint. They will not perform. Not only will they not perform to the capacity that they should be, but they also will not have the low self-discharge performance. The internal impedance on these is just way too high. That's where I would kind of leave it. I would say I would not recommend these. Go with the Eneloops, or I'm going to be testing out the EBL high capacity cells, and we'll see how those compare to the Eneloops as well. The recommendation would be for the longest amount of life, dependability, consistency, and performance. I would recommend just the standard Eneloops. So if you're interested in more battery stuff, then like and subscribe, and I will see you in the next one. Take care.